Hey everyone, so I just want to spend some more time going over a couple more examples of the kind of reasoning we can use to, again, go from a table of information or any kind of way you can present some information about an exponential function and going from that to figuring out how you can actually write the equation of that linear function, okay? So if we look at our table over here, well, figuring out A is the easy part, right? Because the value of A, or the initial value, occurs at the y-intercept, right? That's at the point where x equals 0, right? So in this case, when x equals 0, f of x equals 1/4, right? Okay, so that was the easy part. But I want to go over talking about how we can find that common ratio, right? What can we do to find that common ratio? So remember, you can find your common ratio by taking one output and dividing it by the immediately previous output. Here's what I mean by that, okay? You can take, for example, f of 4, right? And divide by f of 3, right? Or you can take f of 3, right? And divide by f of 2, and so on. Okay, and I want to spend a little bit of time sort of explaining why that is. Because let's remember what an exponential function does. You start with your initial value, right? And to find your next value, you multiply by some ratio. And then you multiply by that ratio again, right? And you multiply by that ratio again. And that's how you go from one value of your function to your next value, right? You're multiplying by the same ratio here. So if we were at, for example, f of 0, right? So let's say this. How would we figure out what f of 1 is, right? Well, we'd start with f of 0, right? And we'd multiply by what? Our common ratio, right? How would we find f of 2, right? We'd start at our last term, f of 1, and multiply by our common ratio, right? And well, what is f of 1? It's f of 0 times b, right? So also we could think of f of 2 as being equal to our initial value times b, or times b squared, our common ratio squared, right? But anyway, the important part is recognizing why this is true, right? F of 1 equals f of 0 times your common ratio. F of 2 would equal f of 1 times your common ratio. And how would you figure out f of 3? Well, it would equal, for example, f of 2 times your common ratio, right? So for example, if f of 3 equals f of 2 times your common ratio, or if f of 2, right, equal to f of 1 times your common ratio, right? Well, we could always divide, right, both sides by f of 2, right? Or down here, we could divide both sides by f of 1, right? 2 in both cases, right? Get our common ratio by itself, right? So in any case, you can find your common ratio by taking f of x and dividing by f of x minus 1 if you have those points, right? And even if we had extra points, we could evaluate like f of 7 divided by f of 6, f of 13 divided by f of 12, and so on, right? So let me clear some space here. Let me clear some good old space here. Okay, there we go. And well, let's try to evaluate both of these particular examples just to make doubly sure that we get the same number, right? Okay, well, what would be f of 4 divided by f of 3? Okay, f of 4 is 4, and f of 3 is 2. What's 4 divided by 2? It's 2, right? Okay, now let's try out f of 3 divided by f of 2. Okay, f of 3 divided by f of 2, right? All right, what is f of 3? It's 2. What is f of 2? It's 1, right? And what's 2 divided by 1? It's 2, right? See, we're going to get the same result each time. So since the common ratio is 2, that means we're multiplying by 2 each time to get to our next value, right? And we should be able to look at our table of values and see that that's the case. See, 1/4 times 2 is 1/2, right? 1/4 times 2 is 1/2. 1/2 times 2 is positive 1, right? 1 times positive 2 is 2, right? Positive 2 times 2 is 4, right? So in general, we know that our common ratio is positive 2. We know our ratio is positive 2. We know our initial value is positive 1/4. So we can write f of x equals 1/4 times 2 to the x power. All right, let's think about another way that we can always find out our equation for a exponential function, okay? So let's look at our table here. So on our left-hand side, we have all our x values, and on our right-hand side, we have the corresponding y values, right? Or the corresponding g of x values. So when x equals 2, the value of our function is 2/9. For example, when x equals 3, the value of our function is positive 6, right? Okay, so just like last time, the easy part here is finding out a. A is the initial value, which takes place when x equals 0. So in this case, our a is going to be 2/9, or 2/9, right? Okay, so how can we find our b? How can we find the common ratio? Well, like last time, if we wanted to, we could always take one value of the function, right, and divide it by the previous value of the function. We could always take g of 2, for example, divide g of 3, right, so on and so forth. Take g of 1, right, divide by g of 0. That's always going to give you the the ratio. But let's think about another way we can solve this, because as usual in math, there's tons of different ways we can solve this. We want to be able to know all the different ways, right? So that our thinking is sort of, I don't know, nimble, so that we have a sort of nimble, adaptable way of thinking about things. Okay, well, so we have various data points here, right? So let's think. We definitely know that g of 0 is 2/9, right? We definitely know that g of 1, right, is 2/3. We definitely know that g of 2 is positive 2, and so forth, right? So let's use this information to see if we can figure out the common ratio. Let's single out this fact. Let's single out g of 1, the fact that we know that g of 1 is equal to 2/3, okay? Well, we also know that g of 1 is equal to 2/9 times b to the first power, right? Because we know that a, right, is 2/9, but we don't quite know b yet. So we're just going to plug in the value 1 into g. So we know that this is the value g of 1, right? And this is also the value of g of 1, right? So we can set 2/9 times b to the first power equal to 2/3, right? Okay, well, can't we solve for b to the first power, right? What's happening to b to the first power right now? It's being multiplied by 2/9, right? Can't we divide both sides by 2/9, right? Can't we divide both sides by 2/9? We sure can. The factor of 2/9 will be canceled out by the division of 2/9, right? And what's b1 going to equal? b1 is going to equal 2/3 divided by 2/9, right? Okay, do we remember how to divide functions? How to divide fractions? We take our fraction in the numerator, right? And then we take our fraction in the denominator and multiply by its reciprocal, right? We multiply by its reciprocal. Okay, and then we know how to multiply fractions, right? We multiply across the top. 2 times 9 is 18. We multiply across the bottom. 3 times 2 is 6, right? Or we can just say, okay, we're going to cancel out these factors of 2. We're going to get 9/3. What's 9 divided by 3? It's 3, right? So it looks like b should equal positive 3. That's what it looks like so far. let's try one more data point just to verify this, right? Because it's always best if you can verify what you think to be the case. So let's take this fact. Let's take the fact that g of 2 is equal to 2, right? G of 2 is equal to 2, right? G of 2, let me make a little bit more room here. Let me get rid of this. Let me attempt to get rid of all of this, okay? All right, of course g of 2, right, is also equal to 2/9 times b to the second power, right? So let's set 2 over 9 times b to the second power equal to positive 2, right? Because g of 2 equals 2/9 times b to the second power, or b squared. And we also know that g of 2 equals positive 2. So we can put that information together and set up the equation we have here, okay? So what can we do? Well, we can divide both sides by 2 over 9, right? So that we get this factor of 2 over 9 canceled out. Therefore, b squared is by itself, right? And what's b squared? What's 2 divided by 2 over 9? Hopefully we remember that we can think of 2 as 2 over 1 in the numerator. We can take the reciprocal of 2 over 9, which is 9 over 2, and multiply. We should know that these factors of 2 will cancel out. We're going to be left with 9 over 1, so we're just going to be left with 9, right? Okay, so what does that mean? Let me make some space here. This means that b squared equals 9, right? Okay, if we take the square root of both sides, b is going to equal positive 3, right? And isn't that just what we got beforehand? It is. So we can be even extra confident that in this case, b is equal to positive 3, right? All right, so now we know that a is equal to 2 over 9. We know that b is equal to positive 3. So we know that g of x is equal to 2/9 times 3 to the x power.